Right, today we're going to do applications of parabolas. So we'll look at a simple problem. A piece of wire measuring 100 centimeters in length is bent into a shape of a rectangle. Let x be the breadth of the rectangle. So if I draw a diagram, it will look like this. The total length of the rectangle is 100 meters, 100 centimeters. We're going to write an expression for the length in terms of x. So we can write down 2 times length plus 2 times breadth equal to 100, right? That's the total perimeter. All right. Now, next bit is, we know the breadth is x. So therefore, I could write 2 length, L for length, plus 2x equal to 100. 2 length equal to 100 minus 2x. And then divide by 2. So divide 100 by 2, 2x by 2, you will end up getting the length is 50 minus x is the expression for the length. Okay, write it down. So let's label that over here. So the length of the rectangle is 50 minus x. Okay. Now, once you got the length and the width, I could find the expression for the area of the rectangle. So area is length times breadth. So you go 50 minus x times by x. And the expression in terms of x, what you need to do is to expand. Let's expand this, expand, so you get 50x minus x squared. It's the expression for the area. Now, after we got the equation for the area, we're going to find and decide suitable values of x. Okay, so this is a practical problem. X cannot take any values. There's a limitation on what values x can take. Now, if you look at the length, it's 50 minus x. So we need to ensure the length is positive, right? The length has to be positive, means 50 minus x has to be positive. Therefore, x has to be less than 50, isn't it? If x is more than 50, then the length will be negative. So therefore, x has to be less than 50. But because x stands for the breadth of the rectangle, x also has to be positive. So it's in between 0 and 50. That's the suitable values of x. So for this problem, the highest value x can be is 50. The lowest it can be is 0. And once you do that, we're going to draw the graph of the area against x. So we're going to draw the graph. We'll draw the graph area against x. Okay. Now remember, the smallest x can be is 0. The highest it can be is 50. Okay. So what you need to do to draw the graph, we need to find the x and y intercept. So how do you find the y-intercept? You substitute x equal to 0. So you do x is 0, so y-intercept. That's where x is 0, area is 0. Okay? And then you find the x-intercept. That's when y is 0. So actually not, a is 0. Yeah. Oh. Okay, x-intercept, that's when a is 0. So therefore you do, actually do it here. So a is 0. Therefore this is 0. So notice it's factorized. That's when x is 0 or x equal to 50. So these are the two x-intercepts. And once you figure out the x-intercept, you can work out the axis of symmetry, which is 25. So put 25 in the middle. And then substitute 25 into the formula. So you do a equal to 50 minus 25 times 25, and then if you use your calculator, you get 625. So that's the highest it can be. That's your vertex. Okay? And then you draw the parabola. So that's the area of the rectangle as the x value changes. Okay? And then you can answer some questions about the parabola. And the most important question is, what's the maximum area that you can make from a rectangle of perimeter 100 centimeters? So the maximum area you can see will be 625 square centimeters. And the dimensions of the rectangle to achieve this is when x is 25, therefore the length is 50 minus x is 25 as well, which is a square. So the largest area it can be is, so it's going to be, so largest rectangle will have dimensions 25 cm by 25 cm. Okay, done. Thank you. So that's this chapter. So you need to draw the graph, answer what's the maximum area or the minimum value. Okay? All right, good. So time.